All right, take a look. Can you believe we're already up to week 8, lesson number 1? We are cruising along in this class, and I really hope, I sincerely hope, that you're starting to perceive things mathematically. Remember, in the very first lesson, we talked about how the song Vincent, about Vincent van Gogh, I think I might have called it Starry, Starry Night. That's the other name for it back then. But how Vincent van Gogh struggled with trying to get the world to perceive the things that he perceived, and that was what his art was all about. And how I remember distinctly working out on a treadmill way back in the day and listening to this song and realizing that I, as a teacher, am trying very hard to get my students to perceive what I perceive, and that you can then, once you assimilate that into your mindset, or in some cases perhaps accommodate, that you could run with it, and it would make mathematics not only so much easier for you, but also that you would appreciate it more. I know that it did for me. Before I was taught to think this way, I really truly hated math. And then once I started to think this way, I started to gain a really strong sense of appreciation for it. Without any further ado, let's see what we're going to cover in class today. Always the homework answers, always the do it. Then we're going to review a couple of types of questions we've been doing, though we're going to limit this today. Then we're going to introduce the quadratic formula, which is kind of an extension of completing the square, which we've been working on recently. One major difference between the two, and then we've got to talk about simultaneous equations. We're going to focus on the system of linear equations, and then we're going to introduce a quadratic linear system, and we'll work more on that in our next lesson that we cover. I really hope this is all starting to make sense for you, and rather than a sense of panic and frustration and what am I ever going to use this for, and this is stupid, it's just a bunch of rules from a teacher, that you're starting to see mathematics for what it is, which really does. I know this is going to sound nuts, but it carries a beauty all its own and explains so much about what's going on in the world around us. All right, so here is our the beginning part of the homework answers. And as always, if you have a hard time with this, you'll reach out to another classmate, reach out to myself via email. But I would say this, I wouldn't panic if you're having a little frustration with questions like number 2, and then when we get to the next page, number 3, it takes a little while to get comfortable with this material, and I'm going to go over this today, and then we've got some more in class, and then our next session will have a little bit more. And if you're still not getting it by the time the next session is done and the homeworks and the do-its and everything else, then you really need to sit down and get some office hours time with me. But by then, I do think you should be pretty comfortable with it. I'll stop and start now. Okay. There's the rest of the homework that you can check out. All right. So here are 2 questions for you to do. Let's have you work on the do it now, and then we'll go over the answers to them. Okay? Okay, assuming you did stop and start. On the first one, factor and cancel, factor and cancel. All that we do is factor and cancel. So I factor n plus 7, n plus 7, n plus 6, and then I factor n squared minus n minus 42. Look at that. I see n plus 6 over n plus 6, which is just another way to write 1, because anything divided by itself except 0 is 1. So 1 times whatever's left, in this case n plus 1 over n minus 7 is just that. So I could just cancel out the n plus 6's. And my final answer is n plus 1 over n minus 7. Now, in case you didn't do that factor and cancel, the next one down is loaded. It's just more factor and cancel. It's just a bigger example of it. Sorry about my dog barking in there. So let's have you try this one if you didn't get it before. And if you did, then you can just keep playing the video. If you did not get it, then please stop the video, redo it, and we'll go over it. Okay, so here it is. I present everything in factored form, and since the tops are already factored, then you don't really have anything to do there. Now, we're looking for anything on the top over the bottom, which is the same. For example, the x minus 3's and the x minus 2's. X minus 3 over x minus 3 is 1. X minus 2 over x minus 2 is 1. So in the numerator, you cancel everything out, which leaves a 1, even though we don't bother writing it, and then over x minus 1 squared. Okay. Let's have you try this particular quadratic equation. I do apologize about the dogs barking. Maybe I do expect a little delivery today, so they might be barking over that. Go ahead. Okay, so we've done this problem at least 2 or 3 times by now, so you should be pretty comfortable with it. There are 2 numbers. As always with algebra, the first one will be x or n, whatever you prefer. But since the sum is 9, the next one has to be 9 minus x. And on previous videos, we've spent a lot of time talking about why it has to be 9 minus x. Suffice it to say, if the first one's 2, then the other one would have to be 7 because they add up to 9. And the way you find out the second one is you subtract the first one. For example, 9 minus 2 is 7. The product of the numbers is 14. So x times 9 minus x is 14. Distributing, 9x minus x squared is 14. There is a tendency on a lot of students' part to think in terms of left and right, move to the left, move to the right. No, you're not understanding math if you're thinking like that. My pastor at church would say, that's stinking thinking. We don't want to think like that. We want that x squared to be positive so that it's a lot easier to factor. So I'm going to subtract 9x and add x squared to both sides. I get x squared minus 9x plus 14. It's so important when you do this. This x squared is positive, so it has to stay positive. The 9x peeking in front is negative, it has to stay negative, and the 14 is positive, it stays positive. When I factor that, I get x minus 7 and x minus 2. Maybe it's the guy on the left that equals 0. Maybe it's the guy on the right. Maybe it's both. Who knows? Adding 7 to both sides, adding 2 to both sides, I get x is 7 and x is 2. And yes, those are the 2 numbers that add up to 9 and have a product of 14. Give this one a try. This is a little bit of a new kind of question. It's similar to ones we've done, but not exactly the same. I did a little diagram for you there. It's a square, so all the sides are the same. Go ahead. Okay, so stop and start time is over. If the length of each side of a square, that's the darker green one here, those are both x, is increased by 6, so this lighter green length is 6, so the whole side now of the square is x plus 6. And if you increase it by the 6, the area is multiplied by 16. Find the length of one side of the original square. So the new square, x plus 6 squared, because that's how you get area, is 16 times the original one, and the original one is just x squared. So I've got to double distribute the x plus 6. That gives me x squared plus 6x plus another 6x plus 16 is equal to 16x squared. Combining those x's in the middle, I get x squared plus 12x plus 36 is 16x squared. And again, don't think in terms of left and right. If you subtract the 16x squared from both sides, which some students instinctively want to do, that would be a mistake because then you would be getting negative 15x squared. We definitely do not want that. We don't want a negative in front of the x squared whenever we factor. So I subtract the 1x squared, I subtract the 12x, I subtract the 36, and that gives me 0, because that's all that's left on the left, equals 15x squared minus 12x minus 36. And I notice right away, thankfully, that they all share a 3 in common. So I divide everything by 3. And that gives me 0 equals 5x squared minus 4x minus 12. Much more workable. But still not easy because it has a lead coefficient other than 1, which means I have to go to plan B here. Multiply by 5. That gives me x squared minus 4x minus 60. When I say multiply by 5, I mean that last term. We multiply it by the leading coefficient. Factor that. That's x minus 10 times x plus 6. Because I multiplied by 5, I have to come in divide by 5. This is old hat. We've done this a lot. That gives me x minus 2 times 5x plus 6 has to equal 0. Maybe it's the guy on the left, maybe it's the guy on the right. X is equal to 2. Then the other side would work out to be negative, right? Because you do subtract 6 from both sides, divide by 5. That would give me a negative. I would reject that answer. So final length of one side of the original square, that length is 2. Okay, solved by completing the square. A little chance to review this before we get into the quadratic formula. Give it a shot. So remember, when we do completing the square, the first thing we always want to do is get the squared part and the x part by itself. So we want that, the x squared plus 14x, to equal -3 by subtracting 3 from both sides. Do you remember what the phrase is that you have to remember whenever you're doing completing the square? Blank and blank. Half and square. Half of what? Half of the 14. So half of 14 is 7. And here's the thing we have to wrap our mind around. X plus 7 squared is going to work out to be, if you double distribute this on a piece of paper, it'll work out to be x squared plus 14x, but it doesn't stop there, plus 49. And there is no plus 49 here. So I have to add 49 to both sides. As soon as I add that 49, I get x plus 7 squared. So that contains the 49. Even though I can't see it, it's contained within that. And then I'm adding 49 to both sides, so I get x plus 7 squared is equal to -3, and then the plus 49 on the left is contained within that expression, x plus 7 squared. On the right, I have to write it out. Now, let's just pause for 1 second and make sure you understand the half and square. Half of 14 gets me the 7. It's the 7 that I have to square. So it's the half of the number in front of the x, the coefficient in front of the x, and then it's the square of that half. Okay, -3 plus 49 is 46. Square root both sides. Oh, somehow the symbol disappeared from here, but under the radical that should say parentheses squared, just like it does above. It should say parentheses squared. That gives me x plus 7, because the square root of something squared is itself, is equal to plus or minus 46. And then subtracting the 7 from both sides. And I get x equals -7 plus or minus the square root of 46. Okay, so that's a reminder of how to do a completing the square question. Half and square. That's what you always keep in your mind. By now, I think you should be pretty comfortable with half and square. The new stuff for today. The first thing we're going to talk about is the quadratic formula. I laugh. I have 2 very fond memories of the quadratic formula. How can you have fond memories of a quadratic formula? How? How? You're a demented human being, Mr. Lindquist, Professor Lindquist. How can you have that? Well, I'll tell you what. The first time I learned the quadratic formula when I was in high school, and I believe I was in 11th grade. Believe it or not, I was accelerated in every single course except math, because I hated it so much and I didn't like it. But then I mentioned to you early on how all of a sudden I met this girl, and that changed everything. And yes, that was what happened. And I'm like, well, now I'm getting into this stuff. I really like it. So as a senior, I actually took 2 math courses at once. I took pre-calculus and AP calculus at the same time. And I loved every minute of it. It was fantastic. I think the last time, before I went to college, I think the last time I had done the quadratic formula was in 11th grade. And I remember sitting in my higher level calculus class in college, and the professor, Tim Lance, at one point he said, what's the quadratic formula? And I raised my hand to answer the question, and I remember how I answered. I'm going to answer it exactly the way I did right now. Kind of the same cadence. I go, x equals -b plus or minus the square root of b squared minus 4ac, and then the whole thing over 2a. And he goes, yes. And I hadn't done it in like a year and a half. But it just kind of sticks in your head. But back then, we used to have to memorize all of these things. And nowadays, at least in New York State, where I taught, they give you the formula on the test. So this is an open book course, so you're going to get the formula. So you don't have to memorize it, but you do have to understand how to use it. So what the heck are A, B, and C? Well, this, what we call the standard form of a quadratic is ax squared plus bx plus c equals 0, right? It's alphabetical, A, B, C. And what these A, B's, and C's are the same exact A's, B's, and C's that are in the formula. So let's do a little bit of practicing finding A, B, and C, because once we can do that, it's just a matter of grinding things out in the formula. For the first equation, 3x squared minus 2x minus 9 equals 0. What are A, B, and C? Okay, so A is the number in front of x squared, B is the number in front of x, C is the number, the constant all by itself. So A is going to be 3, because that's in front of x squared. B is going to be negative 2. Danger, danger, danger. Don't forget to peek in front of that 2 to see that it's negative. And likewise, the 9 is also negative. So C is negative 9. But it's extremely important when we do this for the standard form that it says equals 0. It cannot say equals 2x like this one. So put that in proper form and then find A, B, and C. Okay, so in proper form, this is x squared minus 2x minus 8 is 0. A is 1, B is negative 2, and C is negative 8. Remember, we don't bother writing the 1 in front of x squared, but it is there. In front of the x is a negative 2, and in front of the 8 is a negative. So it's negative 8 for C. Well, I think we should turn around and use this to find a solution to one of these things. Let's solve using the quadratic formula, x squared minus 8 equals 2x. So you've got to start it the way we just did. It's the same exact equation, and then start filling in the blanks. There's a really good chance you have seen this before and that we're just reviewing this. So you're going to start cranking this out on your own, okay? And we'll see what the answer looks like. One of the really cool things about the quadratic formula is it works on every single equation, whether you can factor it or not. So this does always work. Put this in the proper form, find A, B, and C, grind out, crank out that answer. Go ahead. Okay, so A is 1, B is negative 2, C is negative 8. That's what we said before. Plugging them into the formula now. Ready? It's the negative of B. B is negative 2, so it's the negative of negative 2, plus or minus, same symbol there, square root of the B squared. And it's so important, this is really critical, to put that negative in parentheses, because if you choose to put this in a calculator and you don't use parentheses, it can tell you negative 4. In fact, if you have a calculator with you now, try it, particularly a good calculator like a graphing calculator. If you do not use parentheses and you just type in negative 2 squared, it's going to tell you negative 4. Yet, negative 2 times negative 2 is not negative 4. Negative 2 times negative 2 is positive 4. Why did the calculator say negative 4 instead of positive 4? Because the calculator does, and built into it automatically, has the order of operations. And it interprets negative 2 squared not as negative 2 times negative 2. It interprets it as negate 2 squared. 2 squared is 4, negate it, negative, negative 4. If you put it in parentheses, negative 2 squared, that's telling the calculator to square negative 2. That correctly interprets it as negative 2 times negative 2, which is positive 4. So it is critical that anytime you're going to raise a negative to, and technically to a positive exponent, but it's wise to get it done for all exponents, you should have it in a parenthesis. So negative 2 squared is 4, and then negative 4 times 1 times negative 8 is 32. And then over 2 times 1, because A is 1. 4 plus 32 is 36. So now I get 2 plus or minus the square root of 36 over 2. And the square root of 36 is 6. So now I'm going to get, when this plus or minus symbol means there are two answers here. One is 2 plus 6, and then over 2. The other one is 2 minus 6 over 2. It's just a quicker way to write it with a plus or minus symbol. 2 plus 6 is 8, divided by 2 is 4. 2 minus 6 is negative 4, divided by 2 is negative 2. Okay, so those are my two answers, 4 and negative 2. Now, clearly it would have been quicker for you to factor this. That's why we prefer the factoring approach. But if you don't like to factor, if it drives you crazy and you struggle with it, the quadratic formula works for every problem, including problems that you would factor. So if you don't mind taking longer, you can always use the quadratic formula. And one of the cool things about the quadratic formula is that it works for things that are unfactorable, like the one you're about to do. And you can always get a hint, like you try to factor things, you go, man, I don't think that works. But sometimes in the directions, it'll say to express the answer to the nearest tenth, or simplest radical form, which we're really not going to get too into in this course. That means that you're either going to use the quadratic formula or completing the square, either way. All right, here's a question for you to solve using the quadratic formula. Go ahead, work your way through it. I'll show you the correct answers in just a moment. Okay, so get everything on one side. That means I have to subtract the 8. And the a is in front of x squared, so that's 1. The b is in front of the x, so that's negative 3. And the c is at the end, it's negative 8. Plugging it into the formula, x is going to equal the negative of negative 3 plus or minus square root of, make sure you put that negative 3 in parentheses, squared, minus 4 times 1 times negative 8, all over 2 times 1. So that becomes, that becomes 3 plus or minus the square root of 9 plus 32 is 41 over 2, and that's your answer. 9 plus 42, 9 plus or minus the square root of 41. I was doing just under the radical. Let me take it back to the beginning here. The whole answer is 3 plus or minus the square root of 41 over 2. And that's it. You can go no further unless it said to express your answer to the nearest tenth. Then you would look up the square root of 41 on your calculator. And we'll get to some of those in the coming days. But that's it. You're done. 3 plus or minus the square root of 41 over 2. A non-factorable quadratic equation will always have an answer that looks like that with a radical. Okay, let's try one more. 2x squared minus 3x equals 18. Give it a shot. Go ahead. Okay, so 2x squared minus 3x minus 18 is equal to 0. A is 2. It's in front of the x squared. B is negative 3 in front of the x. Danger, danger, danger. Make sure you're peeking in front. And likewise, that's a negative 18 at the end. So that's the negative of negative 3 plus or minus the square root of negative 3 squared minus 4 times A is 2. B is negative 18. Or C, I'm sorry, is negative 18. All over 2 times 2 because A is 2 this time. That's 3. The negative of negative 3 is 3, plus or minus the square root of. Negative 3 squared is 9. Negative 4 times 2 times negative 18 is 144. All over 2 times 2 is 4. That gets us this step. And then 9 plus 144 is 153. So it's 3 plus or minus the square root of 153 over 4. So that means one answer is 3 plus the square root of 153 over 4. The other answer is 3 minus the square root of 153 over 4. All right. So we've covered quadratic formula now. That's an extension of completing the square. And I think that's all of the solving of quadratic equations we're going to do in this course. There are other minor techniques, but those are the biggies, the ones that you really, really should know. Let's have you try this one where you add two rational expressions. And remember, before you add or subtract anything on the face of the earth, they have to be the same kind of thing. And what I'm looking here is, in the case of rational expressions or fractions, I must have the same denominator. That's the thing that has to be alike. And those are not the same denominators. So you need to work on getting that together. Go ahead, give it a shot. All right. So, what is my common denominator or my common category? To do that, I need to factor both denominators. And in this case, each of those denominators have an x minus 3. You see that? But the one on the left needs an x plus 2. So I multiply by x plus 2 over x plus 2, which is a way to write 1. So I'm keeping the value of the left denominator, 4 over x minus 3, the same because I'm multiplying it by 1. And anything times 1 is itself. I'm just writing it in a different form. So that makes 4 distributed here is 4x plus 8 plus, and I don't need to do anything to the one on the right because I already have that denominator. And that gives me 7x plus 6 over x plus 2 times x minus 3. And that's my solution. So hopefully we're now getting to the point where you're like, I'm pretty comfortable with this. And that is one of the, not the hard, as hard as it gets, but it's challenging. Find the difference. Give it a shot on this one. This is all this review section we said we'd do. All about spiraling things, coming back to them. Okay, so what does the denominator on the left need that the one on the right has? That's a 4. And the one on the right needs that the left has, that's an x minus 1. So here's my 4 over 4. Here's my x minus 1 over x minus 1. That is 24, 4 times 6, over 4 times x minus 1, minus, it's going to get a little tricky here in a second, 5x times x is 5x squared, minus 5x over 4 times x minus 1. What's tricky here is I have my subtraction, and then I'm going to subtract this whole thing. So I have to distribute, just like we did before earlier in the year, that negative to both of those signs, which gives me the 5x squared was positive. When I distribute the negative, it's negative 5x squared. Here's the trickier part. This 5x here is negative. Remember, peeking in front. Danger, danger, danger. When I negate that negative, it becomes positive 5x and then plus 24 over 4 times x plus 1. The numerator is not factorable, so I can't go any further. Okay? Maybe you go back and try this again if that last step gave you a hard time. See if it makes sense to you afterwards. Okay, what's the new material for today? So we are going to start talking about systems of linear equations, and this is going to develop. In the next lesson for week 8, we're going to include some word problems and expand on quadratic linear systems. But for now, we're going to start with a simpler type, which is systems of linear equations. And I have to believe that you left high school having seen a lot of this, and that we're kind of reviewing it for you. And then at the end of today and then into the next class, we get into the more meat and potatoes college level work. So what I want you to realize is that there's 2 techniques for solving these type of problems. One is called the elimination method, and the other is called the substitution method. With the elimination method, how do you know to use that one? When I look at the problem and it's aligned, so the x's are over the x's, the y's over the y's, the equals over the equals, numbers over numbers. Let's go over here. X's over x's, y's over y's, equals over equals, numbers over numbers. That is an indication that you should use the elimination technique or the elimination method. Okay? Again, the same letters are on top of each other. X's over x's, y's over y's, and the equal signs are atop each other. For the substitution method, notice that's not the case. X over y, the equal signs are not lined up. Y over x, y over x, x over y, equal signs not lined up. When the same letters are not on top of each other and the equal sign is misaligned, either one of those, that's an indicator that you should be using the substitution technique. Now, let's go examples of each of them. So we're going to solve each of these 4 problems. We'll do 2 elimination method ones and 2 substitution method ones. And remind you, again, you should know this stuff pretty well from high school, but remind you how to do it. Just like when our teacher said to us in that class in college way back when, Professor Lance, what is the quadratic formula? We should have known it from high school. This you should know from high school. So I will take you through and remind you with an aim toward the quadratic linear system we will be doing shortly. Okay, so I notice in this problem on the left that the x's are over the x's, the y's are over the y's, the equals are over the equals, numbers over numbers, and I say, okay, elimination technique. Well, what do you eliminate? Well, it's either of the variables. I don't care if I eliminate the x's or the y's. It makes no difference. It never does. Okay? But there are times when it's a little better to choose one variable over the other. In this case, it really doesn't make a difference. I'm going to get rid of the y's. And to do that, it's a lot like getting common denominators. So remember how we have the technique in getting a common denominator, where if the denominators were 2 and 7, if one denominator was 7, I take the other denominator, in this case the other coefficient, 2, and I put it up top. Okay, I put it up top, and then I take the 7 and I put it down. Well, look at what I have here. I take the 2 and I put it right up top. So it's 2 times the top equation, 2x plus 7y equals 5. And then the 7 comes down to the bottom, times 3x plus 2y equals 16. And one of them, because all the signs here are the same, one of them has to be negated, because that'll make for an easy addition here. Let's just see what happens when I distribute that 2. I get 4x plus 14y is 10. When I distribute the negative 7, I get negative 21x minus 14y is negative 112. And now this is beautiful. Because I have 14y over negative 14y, if I add them, I get 0. And that is a thing of beauty. That's why we call it the elimination technique, because we are eliminating the variable when we line them up. 4x's and negative 21x's added up make negative 17x's. Previously said, the 14y minus 14y, or 14y plus negative 14y, as I prefer to look at it, though it is the same thing, is 0. So the term just knocks out of the equation. And 10 plus negative 112 is negative 102. Now this looks like a normal equation. I know what to do from here. I'm just going to divide by negative 17, and I get x is 6. A little tricky part here. A lot of times students are like, okay, x equals, all done, all done. I don't need to do it anymore. All done. See, I got x. But the problem has x's and y's in it, so you have to go back and get y. You can use either equation. It doesn't make a difference, but you should use original equations. These equations down here, the 4x plus 14y, etc., those are what we call derived equations, and they won't show a mistake if you made a mistake between the question and that step. So go to the original questions. That'll get you the right answer every single time. I can write either equation. I choose to write the top one. 2x plus 7y is 5. Substitute that 6 in for x. 2 times 6 plus 7y is 5. That's 12 plus 7y is 5. Subtracting the 12, 7y is negative 7. Dividing, and I get y is negative 1. So x is 6, y is negative 1. What's the elimination strategy? Well, it's a little like solving common denominators. You have to eliminate either variable. It does not make a difference which one you eliminate. It can be x's or y's. Hint for the next question, I like to choose whichever ones have opposite signs, because then I don't need to multiply by a negative. I only need to multiply by a negative if the signs are the same. Then you just take whatever the coefficients are. If I'm getting rid of the y's, 2 up top, 7 down low. If I'm getting rid of the x's, it would have been 3 up top, 2 down low. So whatever you got to do with those x's, then just distribute and work the problem out. You try the one on the right. Go ahead. Okay, so in this problem, I prefer to get rid of the x's. And if you're really slick and you're thorough on this, you know that you don't need to multiply the top equation by anything. You can just multiply the bottom equation by 2, and then you'll have your x's matched up, 4x over negative 4x. But I do want, if you know how to do that already, you don't need me to teach you this stuff. Just keep doing what you're doing. I'm trying to get understanding into the students and show them strategies that'll work for students who don't understand that. And if that's the case, you can always, what we did before, you just take the bottom coefficient, multiply it by the top, and then the top to the bottom. In this case, I'm getting rid of the x's, so I'm going to put a 2 up top and a 4 on the bottom. Multiplying the top by 2, multiplying the bottom by 4. So I just switch the places with the coefficients. Top comes to the bottom equation, bottom goes to the top equation. Soon as you do that and you distribute, top one is 8x plus 6y is negative 20. Bottom one is negative 8x plus 20y is 72. Look, what a thing of beauty. 8x minus 8x is just 0. It wipes itself out. So I get 26y's, 6y plus 20y, equals 52, negative 20 plus 72, dividing by 26, and I get y is equal to 2. Now, I can then use either equation to go back and get x. I'm going to stick with the top one because I don't like that negative 2 there. That could cause me issues. So 4x plus 3y is negative 10. Substitute that 2 in for y. 4x plus 3 times 2, right? 2 goes in for y, equals negative 10. 4x plus 6 is negative 10. Subtracting the 6, 4x is negative 16. X is negative 4. So y is 2 and x is negative 4. All right. If you had a hard time doing these two, these are the only two eliminations we're going to do today, at least linear systems. If you had a hard time, I suggest you go back and do this slide again. But I also think a number of you will remember this from your high school years, and it will be pretty simple for you. So either way, make sure you understand it before you progress to this slide. Now you'll notice that we don't have the variables lined up. We don't have equal signs lined up. We don't want to use elimination. We want to use substitution. And substitution is a pretty simple idea, all right? Imagine, if you will, that you go to a vending machine. You're at a sporting event. You're watching the game, and to make the problem simple, you want to buy a water, which costs, let's just say, $1. And we've all had this happen to us. We put the $1 in the machine. It spits the $1 back out at us. And we're like, what the heck? And we try it again. And maybe one more time. And then we try to straighten it out more. And we put it in. But sometimes that machine is full of dollar bills. It can't accept anymore. So then what happens is you can look at a friend and you can substitute. You can say, here, you take my $1. You got 4 quarters. I'll use the 4 quarters. And presto, out pops the water that you were looking for. So in this problem, instead of $1 and 4 quarters, a y is the same exact thing as, it's equal to a negative 5x minus 17. A y is equal to a negative 5x minus 17. So then I take the top equation, and I'm going to rewrite the negative 3x. I'm going to rewrite the negative 3, but I'm not going to put the y there, so to speak. It's kind of being rejected. I'm going to put what it equals, the 4 quarters version of the y. I'm going to put in a negative 5x minus 17. Why is that important? Because then negative 3x minus 3 times, in place of the y, I put negative 5x minus 17, and I underlined it to emphasize that I take whatever the y equals and I substitute it in for the y. Equals 3. Now it's a linear equation with just one variable. We started solving these in the first or second lesson of the year. Negative 3x, and then negative 3 times negative 5 is 15x. Negative 3 times negative 17 is 51 equals 3. Same side, same operation. I get 12x plus 51 is 3. Subtracting the 51, 12x is negative 48, dividing, and I get x is negative 4. But I have to go back and get y. I haven't finished the problem yet. I'm not all done. So I rewrite either equation. They both worked, always, but it's so easy with this bottom one. So I just rewrite y equals negative 5x minus 17. I put in the negative 4. I get negative 4 times negative 5 times negative 4 minus 17. And I get y equals 20 minus 17. Okay. That, folks, is better known as 3. So that's your substitution technique. Your substitution technique is to, whichever variable is defined that it says it's equals. If it says y equals, I substitute for y. If it says x equals, I substitute for x. Go ahead, you try the next one. Okay, so I have 5x minus 4y equals negative 3 and y equals negative 3x plus 5. Instead of the y, I'm going to replace it with what the y equals, which in this case is negative 3x plus 5. So notice the 5x is the same, the negative 4 is the same, the equals is the same, the negative 3 is the same, but I change out the y. Out with the old, in with the new. The y is gone, and I substitute in negative 3x plus 5. Hence the name, substitution. So 5x and then negative 4 times negative 3x is 12x. Negative 4 times 5 is negative 20 equals negative 3. 5x and 12x makes 7x minus 20 is negative 3. Adding the 20, 7x is 17. Dividing, and I get x is 1. Always a sense of confidence when it works out to a nice integral value like that. Got to go back and get y. Can always use either equation, but I'm going to use the top one. Y equals negative 3x plus 5 because it's so simple when it says y equals. Substitute in the 1. Negative 3 times 1 is negative 3 plus 5 is 2. Y equals 2. Okay, so that's elimination, substitution for linear systems. And of course, the next class we get in, we're going to do one or two of each again. But I want to bring it up to the next level and hint at what the next class is going to focus more on. Okay? What about this guy? One last type to introduce. And again, we're going to finish the topic next week. A quadratic linear system. Y equals x squared minus 4x plus 6. Y equals x plus 2. I'm going to go through this with you step by step. This is a we do kind of question. The first thing I notice here is that it's really, elimination doesn't begin to get at it because they both say y equals. So this is a substitution situation. And that's the cool thing. You only solve these with substitution, and I get x squared minus 4x plus 6 has got to equal the x plus 2. If the y is the same as the x squared minus 4x plus 6, and the y is the same as the x plus 2, then they must be the same together. Think about it this way. If Bobby weighs the same thing as Jimmy, if they're both 200 pounds, and Jimmy weighs the same thing as Freddie, and he's 200 pounds, don't Bobby and Freddie have to be the same weight? So think of the y as Jimmy. If Jimmy's the same as Bobby, and then Jimmy's the same as Freddie, Bobby and Freddie have to be the same. Since the y is x squared minus 4x plus 6, and the y is also x plus 2, then x squared minus 4x plus 6 must be equal to x plus 2. This is a quadratic. Get it all on one side. I subtract the x, subtract the 2. And I get x squared minus 5x plus 4. Now, this you know what to do. You can run with this. You're so good at it. Go ahead. Factor and solve. So when you factor, make sure you did stop and start. If not, stop this thing now. X minus 1 times x minus 4 is 0. Maybe it's the guy on the left. Maybe it's the guy on the right. X is going to equal 1. X is going to equal 4. Here's the trap. Don't fall into the trap. X is 1. X is 4. What we want to make sure of right now is that you realize there are two variables in this. We don't know y yet. So I have to go back and get y. How do I do that? Well, one possible answer is 1. The other possible answer is 2. Remember, with the quadratic, with an exponent of 2, you get 2 answers. Now I'm going to go back and get y. Substituting into the second equation because it's so much easier. Y is x plus 2. 1 plus 2 is 3. 4 plus 2 is 6. So my first answer is x is 1, y is 3. You can write it like a coordinate. Or second answer, x is 4, y is 6. You can also write that as a coordinate. So we're going to work more on those in our next class. But I did want to introduce it to you today, and I may even put it in on your homework just to have you play around with it a little bit. I think you're going to be able to do it. Have a happy recap moment here. In a linear system, when everything's aligned, it's elimination. When they're not aligned, it's substitution. For a quadratic linear system, you always substitute. There are some serious similarities between arithmetic fractions and algebraic or rational expressions, okay? And we've been following them through. You need to get the same category for things like puppy dogs and kittens. You need a common denominator for arithmetic fractions, And for rational expressions, you also need that common denominator, but you often have to factor first to see what that denominator is. And lastly, the quadratic formula, before you begin using it, you must make the equation equal to 0. All right, that summarizes the keys of what we did today. Ways to succeed in class for the year. Always like to mention this at least once a week. Do all your homeworks when they're due. It's like getting 10% added to your grade if you do that. If you miss one, maybe it's like 9.5 points out of 10. It's not exactly like that, but it is similar to it. How you go about your business is critical. That's the key. You know, I was listening to the Jets coach the other day on a press conference, and one of the reporters said, "What's your goal for the team? How many games are you going to win?" And he said exactly what I have learned from all of my years of coaching. And also teaching. He said, "I know you're not going to like the answer, but I just care that we do everything the right way. We go about our business the right way. If we do that, the wins will take care of themselves." And that's exactly what goes on in class. If you go about your business the right way, the class will take care of itself. Pay attention to due dates. That's part of going about your business the right way. I advise you to work together on projects, collaborate, take pride in your work, show it as best you can. This week there'll be a quiz. Next week there'll be a quiz. But the week after, we might be looking at another project at that point. And that week we might even do a project and a quiz. Because we're in a half-year situation here, I want to make sure we have enough grades. And then the next and last thing is every single day is a chance to realize your dream. What you're looking for out of your life, why you're going to this school. And if you do your job, if you go about your business right on that day, then you're helping make that dream happen. And if not, then hate to be brutal like this, but you're wasting your money. All right? Have an awesome day.